Hi all. Now we can study the remaining rules. Now we can see some block diagram algebra for summing points. Sometimes we have to shift the summing point from a position before a block to a position after the block, or vice versa, in order to find the overall transfer function. So we have to study certain rule. First, we can see the shifting of the summing point from a position before a block to a position after the block. Then what we have to do for that? Consider this summing point R of s, x of s. So output is R of s plus x of s. G of s is the block. So y of s is the output. So what will be the value for y of s? Y of s is equal to R of s plus x of s into G of s, or y of s is equal to, remove the bracket, g of s r of s plus g of s x of s. That is one equation. That is the original output, y of s. Y of s is equal to r of s plus x of s into g of s. Why is it so? The transfer function g of s is equal to y of s by this. So y of s is equal to this much. Now we want to shift this summing point from this position to this position. Then what we have to do? If you are shifting, if you want to shift this summing point to this point, then what will be the output of this g of s? R of s, here it is R of s g of s, or g of s R of s. Then input to the summing point is x of s. So by what will be the output? Y of s is equal to g of s R of s plus x of s. But our original y of s is equal to g of s R of s plus g of s x of s. So here we have to add one g of s. If we want to shift this summing point from this position to this position, this value must be the same. Y of s, it should remain the same, y of s. So but here it is there is a, we want to add a block with transfer function g of s. So what we have to do? Where will here we have to add a block with the transfer function g of s. So here g of s r of s, here also now here the output is g of s x of s. So y of s is equal to g of s r of s plus g of s x of s. So we will get the same output. So what we have to do is we have to remember this rule. If you want to shift the summing point from a position before the block to a position after the block, then we have to add a block with a transfer function g of s. We have to add a transfer function. We have to add a block with a transfer function g of s. Then y of s remains the same. So that's about summing point shifting from a position before the block to a position after the block. Now, if we want to shift the summing point from a position after the block to a position before a block, then what we have to do? Here, here the output is y of s is equal to, here it is g of s r of s plus x of s. The output is y of s is equal to g of s r of s plus x of s. Now we want to shift this summing point from this position to this position, from a position after a block to a position before a block. So it is r of s plus x of s g of s. So y of s is equal to g of s r of s plus g of s x of s. But here only x of s. There is no g of s. In the original case, there is no g of s. But in this case, there is g of s, x of s at the output. So here we have to eliminate this g of s. So what we have to do? we have to add a block with the value 1 by g of s. In the previous case, we add a block with the transfer function g of s. Here we have to add a block with transfer function 1 by gs. So r of s plus 1 by g is x of s into gs. So y of s is equal to again g of s r of s plus x of s as equation 3. So first case we have to add a block with transfer function g of s. In this case we have to add a block with the transfer function 1 by g of s. Now next case is we have to shift. If we want to shift a takeoff point from a position before a block to a position after the block, then what we have to do? Here output y of s is equal to g of s r of s, x of s is equal to r of s. Now if we want to shift this takeoff point from this position to this position, so y of s must remain same. So y of s is in the original case y of s is equal to g of s r of s, but here y of s is equal to same g of s r of s, but x of s is equal to, in this case x of s, actually here the value is r of s g of s, but x of s is equal to r of s only. So we have to eliminate this g of s, so that we have to add a block with the transfer function 1 by g of s. So if we want to shift a takeoff point from a position before the block to a position after the block, what we have to do is we have to add a block with the transfer function 1 by g of s. Just opposite to the case of summing point. For the summing point, if we want to shift a summing point from this position to this position, we have to add a block with the transfer function g of s. Here 1 by g of s. Similarly, what will happen if we want to shift a takeoff point from a position after the block to a position before the block? We have to add a block with transfer function g of s. Y of s is equal to g of s r of s, x of s. X of s is equal to r of s g. This at this particular point the value is r of s g of s. So x of s is equal to r of s g of s. So if we want to shift this, here only r of s is there. So we have to add a block with transfer function g of s. So x of s is equal to r of s g of s. So that is the next rule. Now feedback connection. There are two types of feedback, positive feedback and negative feedback. Okay. This shows the block diagram for a negative feedback system. Here two blocks having transfer function g of s and h of transfer function. This is in the forward path. This is in the feedback path h of s. If we want to reduce this closed loop system, this is the block diagram for a closed loop system. If we want to reduce this into a single block, what we have to do is first E of s is equal to, we know that E of s is equal to x of s minus this value y of s into h of s. Here the value is y of s into h of s. So E of s is equal to x of s minus h of s into y of s. And y of s is equal to, what is y of s? Y of s is equal to E of s into g of s. These are all from the definition of transfer function. Substitute for E of s. So y of s is equal to, E of s is equal to this much. Substitute that into g of s. Now take y of s left hand side. So y of s, and take y of s outside. So y of s, this 1, here it is minus, so here it is plus. 1 plus g of s h of s is equal to g of s x of s. First remove the bracket and take y of s left hand side, then take y of s outside. Then take the ratio y of s by x of s, that is the transfer function, y of s by x of s, the overall transfer function. Y of s by x of s is equal to, then it is equal to g of s divided by 1 plus gs hs. So we can replace this closed loop uh, block diagram for the closed loop system to a single. Uh, we can replace by a single block having value g of s divided by 1 plus g of s h of s. We can replace this by this single block. So here it is minus sign. Please note that here it is minus sign. So in the expression it is 1 plus y of s by x of s is equal to g of s divided by 1 plus gs hs. So remember this expression. It's a very useful expression. So this is for a negative feedback. If it is minus sign, so here it is plus. And now if here it is a plus sign, then it will be minus in this equation. If it is positive feedback connection, then y of s by x of s is equal to g of s divided by 1 minus g of s h of s. Negative, for negative feedback 1 plus, for positive feedback 1 minus. So remember that. So this is the transfer function, the overall transfer function for a closed loop system. For a closed loop system, we can replace the closed loop system by a single block by this expression g of s divided by 1 plus or minus. For negative feedback it is plus, for positive feedback it will be minus. G of s divided by 1 plus or minus g of s divided by 1 plus or minus g of s h of s. So remember this, study this expression. Okay, thank you.